Hello everyone, and welcome back to Stat385. So in this video, this is going to be a relatively long video, but I want to, and the reason for that is because I want to demonstrate a bunch of, I would say, interrelated concepts, and I don't really want to break it apart. So I know the video will be long, but I think it'll be important to, at a high level, see everything that I'm going to do here. So we'll be continuing discussions on the tidyverse. Last week we went into Tibble, what a Tibble is related to a data frame, and went into details on that. And we also discussed visualization and transforming, manipulating the data using dplyr. So in this week, what we're going to do, or particularly in this lecture, we are going to focus on actually obtaining data and loading it into R using Reader. And there's many ways to load data into R, but we'll focus specifically on the Reader package within the tidyverse for doing that task. And we will also focus on tidyr for making tidy data, and in combination with dplyr, then we can make data that is actually useful for some particular analysis. So we'll do a little bit of everything on data wrangling. Okay, so let's go to R script. I know I emphasize it a lot, but I really want to emphasize it in this lecture in particular, that I am inside my R Studio project. In fact, how about I just, in case you don't believe me, I am going to go to my terminal window where you can see where I am at. I'm in Stat385, the directory. I am going to open up the R project. I could have done this from R. In fact, I'm in the habit of working from the terminal, but I could also just close it, open up R Studio directly, and go to projects, Stat385. Okay, great. I'm in my Stat385 directory, R project, and I'm ready to go. Okay, so it's important for this. Okay, so let's see here. Let's first load in the tidyverse. Just have that. Okay, so again, tidyverse contains a bunch of packages. We've discussed dplyr, we've discussed ggplot2, we've discussed Tibble, and today we're going to discuss Reader and tidyr. So first of all, we'll focus on data IO for input, output. Okay, so one way to get data is from packages themselves. So, packages will contain their own data sets. So first of all, base R, for instance, has this air quality data set. So here we have a data set that is just in R, right? We have just here, ready to go. And these data sets are, often useful for example purposes. Also, we had, I think it was Star Wars and dplyr, to demonstrate Tibble. So we talked about this last week when we discussed the differences between data frames and Tibble. But the point here is that for actually importing data into R, this is pretty simple. We just loaded some packages. I guess I should just put these here. And then there's the data, it's ready to go. Okay, so there's also a little bit different than this, packages which have some functionality for reading in data. So for instance, in various labs, we have used this NFL Reader package, and we could, we just load in, how about schedules? Do we have that? Yeah, okay. So here what's going on is that we are referencing the package NFL Reader, notice Reader. So this is very similar to what we're going to be talking about when we discuss reader package. And this is going to like load in some data, and then here it is. It's all ready to go. Okay, so we can now, you can see it here. We have over 66,000 observations on 46 variables. And if we want to view that, we can do so. Okay, there is the data. Okay, great. So now another thing to do or oftentimes I should say, you will have data that you either have on your computer or remote, and you will want to actually load that into R directly. So let's just create a new thing here. Actually, before I go with that, let's just cover a database because we're not going to linger on that for too long. Okay, so you can also load in data from a database. So we're not going to discuss it, but there are functionality within R for establishing a connection with a database that that exists, oftentimes within some sort of corporate organization, and then you would make a request from that database into a local R session to do some manipulations. That is, I guess, beyond the scope of this particular course, but it is something that you can do, and you can do it in R. So if you want to look more, find more resources in that, you can find them on the internet. Okay, so one of the most common ways of inputting data is from local or a remote file, often a comma separated value file. Okay, so one note on this, I think that there is a habit of associating CSV files with Excel, with Microsoft Excel, and that is actually not the case. Comma separated value is just a delimiter or comma is just a delimiter for separating unique values in a data object, and then when it loads in, that can specify the cells, row names, column names, that kind of stuff. So this is a file, or this is a type of file that is broader than Microsoft Excel. Excel has its own internal proprietary way of storing data sets in which we don't have access to. However, it can be. I should note that people have wanted to work with Excel files in R and have written packages and scripts for actually going through the work of converting that into something that can be a data frame. So likely, if it is something that exists and is widely used, some sort of data structure, then somebody has done something to work on it or to load it into R to make it then usable in R. Okay, so CSV broader than Excel. Okay, so let's go to, so I've already actually done this. I've gone to my R project and I've created a data directory, and in it is this CSV file here. Okay, so I got this CSV file from the internet. In particular, I got it from Wade Fagan's GitHub repository. So this is data sets. You can just find this by searching Wade Fagan. Let's do it. Wade Fagan GitHub data sets. And here we are. Okay. So I actually went through the work of clicking GPA, and you can see here getting the CSV file, and it doesn't show anything because it's too big. Viewing the raw file, and here it is. Okay, or you could just download it directly. Okay, so I downloaded it. I created a new directory in my stat3d5 directory, and here it is. Okay, so what I can do is use read underscore CSV. Okay, so my R Studio, R project, has a relative reference So wherever your project is saved, then that is like the reference directory for all files within that project. So I know that I created a data directory and I want to get this particular file. Okay, great. So I'm gonna make a little comment here. Using a relative reference, I'm gonna make a little comment and say that this is reproducible. And what I mean by that is that if you all have created an R project and stored it anywhere in your computer, if you then, in that same directory that you have the R project, create a data directory and then store this file in that data directory, then this code would just work on your computer. Okay, so that's slightly different than using an absolute reference, which can create possible reproducible problems. Okay, so what do I mean by this? So when I type git wd, so this is the working directory in R. So you can see here that the working directory is stat3d5, which is on my desktop, which is in Daniel Eck in the users directory. Okay, so my R project is saved here, right? If I go to stat3d5, you can see stat35.r project. There it is. I'm in the R project. I've opened it up. You all saw me do it. So this is the working directory. This is like the full path to where the R project is at on my computer. Okay, so now I could instead write GPA read underscore CSV. Now note here that I'm getting into what reader is doing. So it's read underscore CSV within the reader package, which is loaded in because I loaded in everything from the tidyverse. Okay, so I could type this path. Oops. And then I know that it's in data and it is called UIC, this thing. Okay, great. So I can load it in. It works. Great. It's fine. So the problem with this is that if you have a different operating system, first and foremost, this path structure isn't going to work. You're also likely not named Daniel Eck and saved a username as this on your computer. So this just isn't going to work. So this is what I mean by possible reproducible problems. If I gave you this code, it would not work on your computer. However, this would, provided that you've created an R project somewhere on your computer, and then in the same place that you created that R project, you created a data directory and then stored the same file there, then this would work. Okay, so for communicating and conveying information, this is better. And this kind of demonstrates the utility of this R project. Because again, I can just go, since I've opened it up, it knows where it's at, or where it's located, and I can just see everything here. Okay, so now some more features of reader. Okay, so if I wanted to instead, so I did everything kind of by the command line using the package, as this is how you would eventually use reader to load in data. But now let's step back and look at like a lot of the user-friendly structure that's built around this. So let me go back to data and let me right click. Pretty sure it's too large. Yeah, too large. Shoot. Okay, let me do it again. Import data set. So you can see here that there's this import window which allows you to view the data set before you do anything. And there's all these options, which I'm not going to get into, but they're there. And then relevant to that is a code preview, which is actually, if you see it, it's what I've done here. Read underscore CSV data UIC, GI, so forth and so on. Here I have read underscore CSV data file name. Okay, and then library reader, I don't need that because I've already loaded in the tidyverse, but it actually gives you the code that it uses to import this data set. Let's just do it, see what happens. Okay, so now reader just ran that code, and then, yeah, you can see library reader, UIC GPA data set is this thing. Used, an assignment operator that I don't like, but that's okay. And then it as a default, put the data set in the viewer so you can see what the variables are. So that is a very nice feature. Definitely, I would recommend doing it a few times just to see how it works. And then when you build some comfortability, then maybe just go right to the command line, or just go right to the command line. It doesn't really matter. Okay, so I hinted at that there are several ways of loading in a data set. So base R has its version, read.csv. And it's in utils, which I believe just comes when you install R. So it's got the different arguments for, how to do this. It doesn't have the nice window that we saw where you could just go say, hey, I want to click this and do import data set. That's a really nice and new feature that did not exist when R was first created, or really before tidyverse. So it's really, for most purposes, it's basically the same, but if you're working with the tidyverse, then maybe you want to use reader, and especially if you want to get like a nice visual of the data set before you actually load it in, then this right-clicking here, import data set within R, is the way to go. And again, it gives you the code that it's eventually going to use. And if you have everything installed and you don't want the viewer, you could just copy this code, cancel, and there you go. Okay, so read.csv. Okay, so another way, and okay, we're going back to using absolute reference, possible reproducible problem. So both of these, everything here so far is loading in a file that exists locally on your computer. We could instead go to source on the internet. Read.csv, and let me go to this link directly. Actually, even better. Yeah. So what did I do to get here again? Okay, so I did view raw, and there it is. I did it in a new tab. Okay, view raw, open link in new tab. Okay, so there's the raw file. So I could just go in and load that in directly from the internet. And tells you what it did. Let's see what happens. So I've technically, I've gotten my object and I assigned it the name GPA. I've overwritten GPA that exists. So let's just see if it looks basically the same. And it does. Okay, great. I should highlight what this data set is. We just loaded it in 3 ways, haven't really talked about it. And I'm not going to do any mini data analysis on it, but this is a list of grading information, like aggregate grading information for all of the classes that exist at UIUC. It's created by Professor Wade Fagan. And so thank you, Wade, for creating this. This obviously doesn't have anything. This is this aggregate information. It doesn't have any unique identifiers, so nobody's grade could be discovered from this. No one in particular, or anything like that. So it's not like we won't get into any trouble looking at this, but it could be something to, you may be interested in it for your own personal analyses. So there it is. Okay. So related to all of this is working directory information. Okay, so, right, so we covered, I kind of
breezed right through this. So in R, there is a working directory where your R session is. When you load in the R packet, or sorry, when you load in an R project, that working directory is going to be the same location as where the R project actually is on your computer. Okay, so we can see where it is. Okay, so another thing to do or consider is that you could set this working directory. You could move where R is, or where the working directory is, by using set WD, set working directory. Now, I would advise against this, because if you're going to do that, then you're going to get back into these absolute references, which contain a lot of user-specific paths or computer-specific paths, and you don't want to be doing that because nothing's reproducible. So if you're going this route for something that you're going to actually communicate with other people, then this is going to break things once you give them the code. So I would very heavily recommend not using set WD, but you can use get WD to sort of see where you're at. Okay, great. All right, sorry, I'm back. I know that there's probably a weird wrinkle in the video right now. Yeah, it was just me and my wife live in the same. We both work from home, and I just wanted to pick a time to record this video that was a little bit with a little bit less going on in the background. Okay, anyway, so we are doing input output, get working directory information. Yes, we don't want to do. You don't want to be living in a. Or you don't want to be working with set WD because you're likely to break reproducibility. Okay, so this is all on input side of data. Just to for a review here, you have data that is built into R packages naturally, that just comes with the territory of loading in the package, and you can just view that data. Then there's packages that have their own loading functions directly into R, where the hard work of actually taking the data from wherever it exists into R is done for you. There's loading data from a database, which we're not going to cover. And then there's the most common type of loading in data, or I should say that I think it's the most common type, from a local or remote file. And you can read it in directly using read_CSV from the tidyverse, using a relative reference, like something like where you have an R project and then you have a data set that's in that is in some directory derivative of where you started from, in this case a data directory. That data directory is located in the same place that the R project is located, and then the file that I want is in the data directory. So you can see it over here. You could also use an absolute reference, but this includes computer-specific path information and it's not reproducible, or you could use an absolute reference from the internet, which we did here. Okay, so now output. Okay, so what do we do when we are done with some data and want to store it, or done doing something? So let's take our GPA data set and filter so that the subject, you can see here, subject is equal to stat. Okay, it's not stats. One little thing, it's not stats, it's stat. That's the code that the university uses. You don't have stats homework, you have stat homework. It's not that big of a deal, but it's a distinction worth mentioning. Okay, so let's take GPA, filter subject stat, and then let's just view this real quick. Oops, view GPA stat. Okay, so here you can see that the subject is all stat. So it did the right thing, and you can get information for the different courses, different year, term, all that stuff. Okay. And you get instructor information and grades. Okay. So I now have a data set that I want to store. And what I can do is write_CSV. You can see here that it's in the reader package. Okay. And I can do GPA stat, and I'm going to use a relative reference. And this is a new file. I'm going to call it GPA stat uiuc.csv. Okay. Watch what happens over here when I run this. Okay, new data set, great. And it's a lot smaller than the overall UIUC data set because we are just looking at information from a single department or subject, namely stat. Okay, so there's all kinds of different write functions, as we saw, for different types of objects, but the most common one, at least the most common one that I have encountered in doing this in practice, is CSV files. So that's what we're teaching here. Okay, so now on to, I'm going to make a new, so Command-Shift-R, tidy, hope if I spell things correctly. Okay, so let's reorient ourselves. Okay, so we've done Tibble, ggplot, dplyr, reader. Now we're gonna do tidy, making tidy data. And let's go back a little bit. Tidy data. So each variable is a column, each column is a variable, each observation is a row, each row is an observation, and each value is a cell. Okay, so we have variables in the columns, observations in the rows, and cells specify single values. That'll be important as we go through this. Okay, so here is a set of set of stock data sets within Tidyverse. If I could spell tuberculosis. Okay, so they're given these very descriptive names: Table 1, Table 2, Table 3, Table 4A, Table 4B, and Table 5. So let's look at each one of these. Okay, I'm just going to clear this out. Okay, Table 1. This is tidy data. There's a good example of tidy data. So here we have each column is a variable, and each row is an observation. Okay, so there are a little bit of like repeats in the country name, but we have that's because there's been records across years. So each value of this, or each cell, each value of this data set gives gives like a unique observation for something that was collected on, say, country, year, cases, population. So this is total population of the country, total cases of tuberculosis, year, and country. Okay, fairly straightforward. Perhaps to demonstrate what tidy data is, we should look at things that aren't tidy data. Table 2, for instance. So it's very, very similar. However, we essentially have double the data here. We have 12 rows, 4 columns, and basically we have count, which is, it's really strange, right? Because we have counts of 2 separate things in this column. So like if you wanted to take average count, that wouldn't make any sense, right? Because there's counts per different types. Okay, so that's not really tidy data. And then table 3, it's pretty obvious to see what's wrong with this one. There is a rate that is also in character form because it couldn't really, express this information in numeric with the divide operator there. So that's ugly. You would, maybe you would want a rate in some analysis to compare different countries and see which one on like a per 100,000, population basis, see which one has the highest rate of tuberculosis. But that's something that you can, if you have the sort of the raw data, you can then get different variables for different analyses that you want. But this doesn't tell you anything about the raw variables. I mean, it does, but it's not very user friendly. Okay, table 4A and 4B. There's a lot wrong here. It doesn't even meet the premise of tabular form. All the data is technically here, but we have year divided out in the variables. And here we have a specific table for cases and another one for population. Not good. Okay, and then table 5. Well, okay. Well, we know it's wrong because the rate column, and there's just no need to specify century and year differently like this. I mean, I guess you would maybe want to know some sort of seasonal pattern among the years, but you could, again, start with the base data using year in the more conventional form, and then, investigate that thing in some, very detailed analysis. Okay, anyways, the exercise that we're going to be doing is essentially taking these problematic tables and converting them into table 1. So here's our goal, is to have country, year, cases, population, and all of this observation information. Okay, so the functions that we are going to do this are pivoting. So we have pivot longer, pivot wider, unite, and separate. Okay, so these take data sets and convert them into like a different format, or take tabular data sets as input, and then output tabular data sets, where here we could take table 1 and we could write it in a longer format where we would have this that count for that column for count, and have multiple observations on the same subject within kind of this long form. Not exactly tidy data, but something that can be useful in some ways for creating tidy data. Sorry, I'm being very vague here. And also I should say that data in this sort of long format with count, let me just go to table 2, can be useful in some analysis capacities, like, I don't want to go down this rabbit hole, but there's a particular type of model that I do research on where it's important to have the multiple observations per individual in this common count variable. That's going to get down. I don't want to get into that too long, or too much detail, but pivot longer is useful for creating that type of information. Pivot wider is useful for taking the long form and suppressing it, and converting it into the wide form. So that's going to be extremely relevant for what we're going to do with table 2. And then unite can kind of compress columns together, and separate can separate out things that exist in the column into multiple. And if you think a little bit about what these different tables are, you can maybe sort of logically see where we're going to go. Okay. So table 2. Command-Shift-R. All right. So let's just load up table 2 again. There it is. Okay, so what I'm going to do is pivot wider, and you can see all the arguments here. And the one that we're going to use are from will be the key word here. So what I want to do is names from type. So I'm going to so essentially in table 1, we have variable names for cases and population. So I'm going to get those names from the type, and then get the values from count. So this is going to use some magic to know that the different variables that I want are encoded in type, and the corresponding values are from count. So it will take cases, create a new column for it, put 745 in that column, and then create a new population or new variable for population and get this corresponding value. So let's look at it. That looks like table 1, right? Pretty good. Yeah, so they're the same. Okay, and we can check this. So how about I take what I did here and do identical table 1. Good. So we started with the non-tidy data in table 2. Mostly it separated out variables. It contained multiple variables in one column. And then we converted it into tidy data using pivot wider. Okay. Great. All right, let's go on to table 3. Okay, so what's table 3 look like? Oh, we have this rate thing. All right, so we are going to do separate. Okay, so let's see. We need to specify a column that we want to separate, and that would be this rate column. What happens if I just run it? Okay, so I have to specify the column that I want to separate and the columns that I want to separate them into. Okay, cases and population. Okay, looks pretty good. However, we can see that it is not quite the same as table 1, and the difference is relatively subtle. So the issue here, oh, you can actually see how it's left justified and right justified. Anyways, the issue is that this rate thing, variable, was encoded as a factor variable, and then so when you did the separation, it took a big factor and just separate out into 2 factors. Okay, and then I should note that there's a little bit of magic that's happening under the hood. Basically, the function can try to find some sort of common delimiter and then just guess that that is the delimiter. And so here it found this division sign as the common delimiter and actually did pretty much the right thing. Okay, so we got a little bit of, we got a lot going on. First, I don't like the idea of having it guess. If I do that, oh, that's not the delimiter. I need to specify it. Okay, it's a little bit better. Doesn't fix our overall problem about the type being character. So I could do 2 things. I could go, I'll do sort of the standard slow practice. Mutate cases equals, what is it in table 1? What's the type? Table 1 has double. Okay, as dot double cases, and population equals as dot double population. Okay. Yeah, looks pretty good. Alternatively, there is an argument called convert, and it will just guess at a type. Here it just specifies integer. It's fine. Okay, so great. So now this is very similar to table 1. Okay, so we took the non-tidy data and converted it into tidy form. Okay, so table 4 has a lot going on because it has those 2 parts. So let's just skip it and just go right on to table 5. Okay, what is table 5 again? Oh, so I can see right away that I want to do some similar stuff that I did in the previous. So I had a rate. So let's do that, see what happens. Okay, so now I have cases population. I have that stuff. Okay, now I want to take century and year and kind of smash them together. Well, if I had separate then, and I hinted at a function called unite, I think that that's going to be the way to go. Okay, so let's do that. Unite. Sorry, I'm getting a little bit off the windows here, or off the rails. Okay. So call that I want is I want to create a new column called year. And I want it to unite the columns century and year together. Okay, Okay, just 1 second here. So I'm going through this rather fast, and you may think like, how do I know this? Well, I've worked with it before. I'm not going in as much detail as I went into like, say, like vectors, which are just like, the main concept in R, and then we, went into immense detail on what vectors are, different types of vectors, different, atomic, generic, list, data frames, and all that stuff, and dive into detail. Here, there's so many things that you can do with tidy, with manipulating tidy data and dplyr and ggplot and all that stuff, that I'm presenting more of a broad overview of the things to do. However, and if you want to, then you can get a sense about what exists. And if you need details on specific things for a specific analysis, then you can read the documentation. So mostly it looks like I'm just pulling stuff from out of thin air, but I'm just presenting a broad overview of many concepts that exist within the tidyverse, and then specifics can be found in the documentation. However, here I think that the default way of working with Unite is a little bit unintuitive. So call is this argument supports. The aim is captured from the expression. Okay. So you can see here. So you can kind of get a sense of what's going on from the help page, from the documentation with these examples. So I want to create a new column X, Y, and I want that to be from the columns X to Y in this data set. Okay, that sort of makes sense how that's going to work. Okay, so I want to create a column year, and I want to combine century and year. And I know that it's really strange, but that's because in this data set, they took out the century information from the 2-digit code for year separately. But like the standard way of referring to century plus year in this way would just be year. So that's why it's working. Okay, let's run it. It works. However, we can see that there is this underscore, which is rather annoying. So there is a sep argument. This is what the default is apparently, right? Yep. And I want to make it blank. There we go. Okay. So note that by combining all this information together, it's converted into a character again. Let's see. Convert. There is no convert. Let's see if I just throw it anyways. Error. Annoying. Okay. So let's get rid of that. And then do you mutate year equals as dot double year. Okay, great. So we have a character vector for country, year is a double, and we have integer values for case and population. Sure. I know that there's a little bit, if I wanted an exact replica of table 1, I would do a little bit more in the mutate direction here, but I'm okay with it. Okay. So now let's do table 4. Okay. The infamous table 4. Okay, so let's get table 4A, table 4B. Okay, so we have a table for counts and a table for populations. And we have, although it looks like it's in tidy form, I would contest that a variable or a column name should not be a variable that itself could be an important in some analysis. So there's a lot of things going on here. So first of all, what do I want to do? We're gonna have to combine things together. So let's create separate data sets here and store them. Table 4A tidy. Okay, so first of all, so this data is in a wide format because we have a variable as a column, 1999 and 2000, and we'd want that to be years. So if we want to convert to take wide, the variable specifying the columns and extract that as a variable with values, we want to make it longer. Oh yeah, so there is a case where, yeah, pith longer is going to be used to create tidy data. Great, sorry about earlier. Okay, so the columns I want to work with are 1999. So by default, R does not let you specify number columns, and so hence these tick marks. Okay, and I want to use names too. So before we had, when we used pivot wider, we did from. Here the operative word is to. And names to, give it a name, year, and then the values that are in the current table are cases. How's this look? Oh, values 2. Whoops. Okay, looks good. Year's a character. We'll do that at the end. Okay, so let's take the same thing, the exact same thing, and I'm gonna highlight everything. I'm gonna do Command F, and I'm gonna just search for A and make that 4B. It should highlight in selection, and it does. Okay. And then I need to do names to year, values, population. Okay, how's it look? Looks good. Okay, so now I have I have cases and I have population in tidy form. Still two separate tables. So now what we are going to do is join them together. And you can see here, note that basically all I want to do is take this column, population, and then just add it to this data set. So the function to do that is left join. Why left join? I'm taking the thing that's on the left in the notation, and I'm taking the thing on the right and taking the unique, or the columns that I want, and just joining it to the thing on the left. Why is it the thing on the left? Because I'm going to specify it that way. So here is my table on cases, and then here is my table on population. And basically this thing has two columns that are the same as this thing. And so and then this tidy has a column for cases that doesn't exist here. And this one has a column on population that doesn't exist here. So it's going to take those columns that don't exist and then just append them to this data set. I guess it's easier done than said. Okay, so that's how it works. However, in most cases, I mean, this is great, right? It's just one line to do this task. However, I think that that's a little too fast in a way where it allows you to create errors. So how about I specify the join variables directly. So these are the two variables that are common to both data sets. And then whatever isn't common is just going to get joined. Whatever that isn't common from 4B tidy is just going to get joined to 4A. Okay, it's a little bit better. And now I contend that I want to get rid of that year variable, which is not get rid of it, turn it from character to double. Year equals as dot double. Okay, double year. All right, good, looks good. Okay, so that's that. I'll do another example now that we'll use this flight data. NYC flights 13. Okay, and we'll demonstrate this stuff along with the tidyverse. Just 1 second. All right, so let's see here. So we have our, oh yeah, I need to load it. NYC flight 36, sorry,
Flights 13. Okay. And then let's consider a subset of the data. Flights. Let's look at, so this is all the flights from the New York airports, Newark, JFK, and LaGuardia for the year 2013. Let's further restrict it to, let's say, Halloween flights. Day equals 31. Okay. 922. Tibble with 922, 19. And let's just consider a snapshot of this data. Looking at scheduled depart time, carrier, flight. I don't care about flight. Let's just do origin and destination. Okay, just really simple. Okay, so now we have scheduled depart time, carrier, origin, destination. Okay, great. Now, in looking at this data set, I don't really know what the carriers are. I mean, I think this is American Airlines, is probably United. And I know that I'm not very good at FFA triple letter acronym codes for the airports. However, I do know these ones because it's so vital to the data set: Newark, JFK, and LaGuardia. However, I'm guessing that's Miami. I'm guessing that's Boston. I don't really know what these are. Okay, so how this information exists both for the carriers and airlines. So we have a code here. So B6 is JetBlue. Okay, wouldn't have guessed that. I guess DL is guessable. Okay, and then I also have information about the airports. Okay, so here's the FAA code and here's the name. Okay, so if I want to take this data set here, these airlines and airports, get the names for them, I can do that and add that to our trimmed data set here using these joins. So let's go ahead and do that. So, okay, so I have my variables. I want to left join airlines. So here inside of a pipe operator in this nested sequence of dplyr commands, it's going to know that I want to take the inputted data set and join it with the thing that I'm currently working on, which is this. So, okay. So now I want to, let's see, by carrier. So is the name the same in flights? Where's flights? Flights. Right, so I have carrier and I have carrier. So these are the same names, so that's easy. By equals carrier. And also it's nice because there's only two variable names. So this is going to take, even though that this is a 16 by 2 tibble and the other thing is like 922 rows, it's just going to take, it's going to find the carrier code in flights, and then it's going to map the name, the carrier name, to the carrier code. It's using this variable, so it can work when things are different dimensions. So that's nice. So now I have carrier name. Okay, so I don't like how that was organized. So let's take select scheduled depart time, carrier name, and then everything else. Okay, good. And then I believe there's name for the airports, so I don't want redundant names. So I'm gonna do rename, and I'm gonna say carrier name equals name. Okay, so now I have scheduled depart time, carrier, abbreviation, but that's just the standard way of communicating this information, I guess, for
in the flights data set. And now I have carrier name to go along with carrier, and then I have origin and destination. Okay, so I want to do destination airport as well. Okay. So, oops. I want to left join. Now I want airports. Okay, there's gonna be a little bit of snags here. So airports has a lot more variables. There's FFA, name, and then different variables on these airports. Okay, so I just want name, but whatever. Okay, so wait a minute. So FAA is the variable name in airports, and in flights, it's dest. Okay, so I just see here. If I do by dest FAA, so again, broad overview. Now that we're stuck, we're going to need to go into the documentation. I think I still want to use by. Lots of different join. There's a lot of different join functions and different like merging functions. With few exceptions, very few exceptions, and maybe even due to me using base R functionality, almost no exceptions. I use left join. The other ones, I guess, they're important, and there may be specific cases where you would want to use them, and maybe you'll come up with a case where left join is not the thing that you want to work with. In that case, investigate the others. But and so I'm going to let you know that those exist. However, I'm going to work primarily with left join because in practice, at least in my experience, that's the one that is the most important. Okay, so here's this by argument to join by multiple variables, to join by specification of multiple expressions. Okay, so for example, join by A equals B, C equals D will match X $A to Y equals B. Okay, so I need to do something like that. So, oh, join by. Oh, here we go. Oh, by. Whoops. Sorry, I was in join by. Okay, I need to do equals. There we go. Great. Let me just make this bigger. Okay, so we get a little bit more information. It's kind of suppressed. Okay, so a few things going on here. I don't want all these other variables. So let's get rid of them. And I want to select, so let's see here. I'm going to select minus, I believe it's lat colon T zone. So I want to get rid of those. Okay, now I have name. Okay, there's a little bit more here. Oh yeah, MIA is Miami. Great, I knew one. And let me do a rename. Another rename. And I'm going to do dest name equals name. All right, great, awesome, we're done. Okay, so I have dest name, carrier name. Okay, cool. So nice. All right, so I think I'm going to stop here. That's a lot. So in this lecture, we have covered, let me go to the end here. We have covered how to read data into R using the reader package with a focus on, I would say, directory organization. So I worked within my R project for this class, and then that sets as default R's working directory to be whatever it is where the R project is located. And then I created specific directories within that location to put data into so that I could have a common reference that is, in a sense, reproducible, this thing right here. If you have an R package located in some directory and then you create a data directory and then put your data set with the same name in that data directory, then this code would just work for you. This is the way to go when loading in data sets into R. There's also absolute references. This one's problematic. It specifies computer path information that is particular to my or anyone else's computer and won't work on another system. Then there's also absolute references pointing to the same website. That's reproducible, provided you have an internet connection and things don't change. Okay, then we discussed writing data. And then finally, tidy data, what it is and how to get to tidy data. And then we ended with a combination of tidy data and dplyr together to do just all sorts of like fun wrangling. Okay, so if you made it to the end of the video, very good job, and I will see you next time. All right, take care. Bye.